The next one. Okay, so I'm going to type in this one. Negative x minus 4 squared plus 9. Actually, give me 1 second. Okay, so I'm going to write negative x minus 4. Okay, so I'm going to get rid of this. I'm going to write f of x equals negative x plus 4, shift 6 to the second power, and then plus 9. Okay, I'm going to change this so we can see it a little better. Blue? No, let's make it red. Okay. So, it says vertex, so that's where it turns, or the corner. So that's right here, negative 4, comma 9. Let me actually click that. There we go. Negative 4, comma 9. So the quadratic function has a vertex at negative 4, comma 9. The vertex is a minimum or maximum. Let's see. So that's the highest point. That's the highest point. So it's like, ooh, that's the highest it goes. That is a maximum. Direction. So I'm going to sketch this real fast. It goes like this. Or, you know, a little better, I guess. A little more symmetrical. Okay. So max. The parabola opens down. So that's opening downward. Like, remember, this would be upwards. And this would be downward. Like, it's opening that direction. So this is opens downward. Axis of symmetry. So axis of symmetry. Remember, our axis of symmetry. Well, let me explain it like this. Our axis of symmetry is going to, remember, we have a symmetrical parabola. This thing is a parabola. The axis of symmetry is the line that cuts it in half. The axis of symmetry is the line that cuts it in half. It being the parabola, right? So we go to negative 4, 9. So let me see. Negative 4, 9. So we have negative 4. So like the line here would, right? Where we have negative 4, 0, negative 4, 1, negative 4, negative 2, negative 4, 3, negative 4, 5. Like it's all up and down this thing, right? So that's where the x is always negative 4. That's where x equals negative 4. Let me change that color. Blue, maybe. Let's try blue. Okay. So this line cuts the parabola in half, and it's perfectly because it's symmetrical. The parabola is symmetrical about the line x equals negative 4. X equals negative 4. The y-intercept. So it crosses the y-axis. We want to look at where it crosses the y-axis, okay? So it looks like we're going to have to drag this down a little bit, I think. So this is our y-axis. This is our x-axis. So it crosses the y-axis right here. 0, negative 7. 0, negative 7. Oops, there we go. It crosses the y-axis. Oops, let's make that a little bit better. At 0, negative 7. I can make that look a tiny bit better. 0, negative 7. Cool. Now we're going to talk about the roots, the zeros, the x-intercepts. The x-intercepts. So let's look at where it crosses the x-axis. The x-axis. Let's drag this back up. We can see it crosses the x-axis right here and right here. negative 7, 0, and negative 1, 0. Negative 7, 0, negative 1, 0. Negative, oh, so there's two of them. One is at negative 7, 0, right? If I remember correctly. Yeah, and negative 1, 0. Okay, now we got to find some points that we can use on here. So I'm going to, well, it might make it easier if I do this. Remember, I click the cog, and then I make a table. Okay, we can see with these are nice. So I want to do 1, negative 16. Let's do 1, negative 16. Oops. 1, negative 16. So 1, negative 16. So what is the value of f of 1? Remember, that's our x. F of 1 is negative 16. I'm going to write that slightly different. Something about it looks a little messy. I think it's just the fact that it's a 1. Remember, f of x, f of 1. F of 1, so f of 1 is negative 16. Cool. When does f of x, okay, oh, let's choose a different one. We could choose the same point, but that's a little lazy for me. I want to show you something else. So we have 2, negative 27. So remember, well, this is when does f of x. Remember, f of x is y when you put it together. That's the x, but when you put it together, f of x is y. When does f of y, the y, when does f of x, or the y, equal negative 27? It equals negative 27 when x equals 2. So y is negative 27 when x is 2. But remember, there's usually another one. So I'm going to look at, so this is 2, negative 27. So 2, negative 27. That's that one. Wait, no. That's 2 right here, right? So we got to keep going down. Negative 27. 2, negative 27. But there's also one symmetrically across the vertex, right? So there's one right here. Can we get to it? Oh, there it is. Okay, it's not staying, but negative 10, negative 27. So we also have negative 10, negative 27. So it's also when x is negative 10. So be careful. The only time you're ever not going to have two answers here, or two x's here, is if you choose this point. Like if you choose this point, the symmetrical one is this point. Ooh. I can't, there it is. So there's two of these, negative 2, 5 and negative 6, 5. If you notice, there's one on this side, one on this side, because you're looking at the 5. So right here, there's 2. There's 2. So whenever you look at the f of x equals something, always be sure, like check for the other one. The only time there's not, once again, will be if you choose this point right here. So that's it. Thank you.